Okay, YouTube, this is my first video, my second module on plotting complex numbers in polar form, in which we're going to basically work with multiplying and dividing and raising to powers and taking roots of complex numbers, but doing it in polar form. And so as sort of a warm-up, what I'd like to do here is just, I've given us a couple of numbers that are complex numbers, one in rectangular form, this a plus bi form, and the other one in r cis theta form, or r cosine plus I sine of theta form, or in polar form. And so what we're going to do is basically plot these numbers and then convert them either into polar form if it's in rectangular, or vice versa. If it's in polar, we'll put it into rectangular. So looking at this first example here, let's go ahead and start by sketching, as we've been asked to do here, this complex number in rectangular form. Now remember that when we're graphing complex numbers in rectangular form, we have our real axis and our imaginary axis here, imaginary. And so when we graph this number 3 plus 4i, we're going to go 3 to the right on our real axis, 1, 2, 3, and we'll go up 4 on the imaginary axis. And we'd say that this complex number, we would plot it right there. And we could even label this. This is the number 3 plus 4i. And so with respect to this number here, what we're attempting to do is put it into polar form. And so in terms of polar form, we already know the values of x and y here. We'd say our x value for our complex number, or we could really say it this way. I shouldn't use x and y. A plus bi, our a value here is 3, and our b value here is 4. So using these values right here, the two values that we're going to be seeking here really are theta and r. And if those are the things we want to find, then let's go ahead and use some relationships that we're already aware of. Starting with this, we could say that finding r, looking at this right triangle situation, is as easy as using the Pythagorean theorem. So we'd say with our complex numbers in standard form, or in rectangular form, a squared plus b squared is always going to be r squared. So it is the case that r is always the square root of a squared plus b squared. So let's go ahead and evaluate this here. We say r is the square root of 3 squared plus 4 squared. This ends up giving us a 9 plus a 16, which really is the root 25 here. And it comes out to be 5. So one thing we know right now is that our r value is not theta, our r value is 5. I'm going to go ahead and put this up here on our illustration. Now the other thing that we want to find here is theta. And let's recall that the tangent of theta, okay, the tangent of theta would be a over b, where a and b are just the parts of our real number here, or our complex number here. And pardon me, this should be b over a. So looking at our diagram here, we'd say our imaginary part over our real part here, or 4 over 3, that would be the tangent of our angle theta. And so if we know the tangent of our particular angle theta here is b over a, that gives us 4 over 3, then to solve this equation, what we'll do is we'll take the tangent inverse of both sides. And so we'll take the tangent inverse of everything on the left, the tangent inverse of the tangent of theta. On the right side, we have the tangent inverse of 4 over 3. So in other words, we get our tangent inverse and tangent to cancel out. We get left with just our angle as this tangent inverse of 4 over 3. So we're just going to use a calculator here. As a matter of fact, I'll just use my Apple calculator, and we'd say 4 divided by 3 is 1.3 repeating, and then we'll do a tangent inverse on this. And so our angle is about a 53-degree angle here. So theta, approximately 53 degrees. And so what we know now is that our r value is 5 and our theta value is 53 degrees. Then to write this number in polar form, remember that polar form tells us the r times the cosine of theta plus the I times the sine of theta, and we just write our I up front so that you don't think it's part of this angle. But we'd say that this is our polar form number. Well, if we know that our r value is 5, we say 5, we could write that in, and we know our angle is about 53 degrees, we could say this is 5 cosine of 53 plus I times the sine of 53 degrees. And we could see that that's the same point here because we would have rotated 53 degrees and walked out positive 5, or in the direction of that 53-degree angle. Now, with number 2, we want to start by plotting this complex number that's already in polar form. So we have r is 3, and it looks like our direction here is 60 degrees. And so what we're going to do is we're going to rotate 60 degrees. That'd be a long, maybe this angle here is almost a 60. Then we'll go out 3 units from the origin. I tend to just say, hey, look, this looks like a 60 here. And I know that this is 3 just because, let me label this here, just because I said so. So with respect to what it is that we're trying to find here, we're trying to find the values of a and b in this situation so that we could go back and we could rewrite this number in z equals rectangular a plus bi form. So with respect to a and b, let's remember this here. We could actually solve for this using SOHCAHTOA math. We could say that the cosine of 60 degrees would be a over r. We could say cosine of 60 degrees is a, the adjacent side, over r is 3. And we could say that then really a is 3 cosine of 60 degrees. In general, though, we had said in the past that if you always want to solve for a, it's always going to be your r value times the cosine of this angle right here. And so we could say that this is our a value right here, but more generally speaking, we would say the value of a is always r cosine of theta. And the value of b, by the same right, using a sine relationship instead, we could say the sine of 60 degrees. The sine of 60 degrees would have been b over r, and so we get b is 3 sine of 60 degrees. It's just good to know that our y component there is r sine of theta. So using these right here that say, look, if you know r and you know theta, we could go plug these in and find a and b, then we're going to get some values for a and b here. And so with the cosine of 60 degrees, because I know the cosine of 60 degrees here, the cosine of 60 degrees is a half, I'm actually going to substitute in a half for our cosine of 60 there, and I'm just going to multiply our 3 times a half. We get 3 halves is our a value. And then with respect to b, this is the same thing except with a sine value. We say b is 3 sine of 60 degrees. Now our sine value at 60 degrees is root 3 over 2. So we get 3 times root 3 over 2. So to be exact about this here, we would say that our complex number in standard form or rectangular form would be a, which is 3 halves, plus b, which is 3 root 3 halves, I, and I'll put my I over here. But this would be our standard form or rectangular form number. And we could see how if this were 1.5 and this was 3 times root 3 over 2, that would make reasonable sense that we'd have a 60 here and a 3 as our R value there. So in the next video we're going to do is we're going to learn how to take this long elongated form of polar form of a complex number and shorten it a little bit in preparation for using operations with our complex numbers in polar form. Cheers.